Okay, now we're going to start on chapter 8. First of all, what we're going to look at is random variable. A random variable is a numerical value that describes the outcomes of some random phenomenon. Like for instance, x. We're going to let x equal the number of heads obtained in tossing a coin 3 times. If you get 0 x's, it's 1/8. To get 1x, it's 3/8. 2 x's is 3/8, and 3 x's is 1/8. And that's what a random variable is. And you'll have questions regarding what a random variable is. All right, first of all, what we're going to do is let's pretend we're going to flip a coin 3 times. Here's my outcomes. All right, I have 8 of them. So we're going to define x as the number of heads obtained. X will vary from 0, 1, 2, 3, but will always be one of those numbers. How likely is x to take over one of the values? That's the question we're going to discuss right now. The probability distribution is as follows, like I covered earlier. 0 x's is 1/8. 1x is 3/8. 2 x's is 3/8, and 3 x's is 1/8. If I were to draw a histogram, it would look like this. I put 0 down here, 1/8, 2/8, 3/8. Here are my probabilities on the left-hand side. The values are the 0, 1, 2, and 3. And again, you just mark accordingly. Now, what we're going to do is I'm going to show you 3 things. We want to know what the probability is of getting x is greater than or equal to 1. And there's 2 ways we can do this. We can take the probability of x equals 1 plus the probability of x equals 2 plus the probability of x equals 3, and that would give us our answer. Or we could do the complement rule, which is 1 minus the probability that x is less than 1, which would equal 1 minus the probability that x equals 0, which would be 1 minus 1/8 equals 7/8. All right, the next thing we're going to do is we're going to talk about expected value. Expected value is multiply each possible value of the variable by its probability, and then we're going to summing adding overall possible outcomes. In other words, what we're going to do is your values are x1, x2, x3, all the way to x to the sub k, and then you have a probabilities of p1, p2, p3, all the way to whatever the probability of k is. And the way you find expected value is you take your x1, you multiply it by its probability. You then add it to your value of x2 times its probability, so on and so forth till you get to the very end. Now, one thing we're going to talk about is APGAR scores of newborn babies. It's how a baby is scored whenever it's born within the first minute. All right, so the values are as follows. 0 through 10 is the score, and then we have the probability. What's the average APGAR score of a newborn baby? Well, what we're going to do is we're going to define what y is. Instead of x, I'm using y. It's okay. We can use various letters. APGAR, let y equal the APGAR score of a randomly selected baby 1 minute after birth. Here's how you find the expected value of y. You take 0, which is the score of 0, times the probability that that baby got a 0, plus 1, a score of 1, times 0.006. So basically, I'm going back up here, and I'm multiplying 1 times 0.006, 2 times 0.007, and I'm adding them together. When I get to the end, I get 8.13, and you follow up with a sentence of the mean APGAR score of a randomly selected newborn 1 minute after birth is 8.13. And that's basically how you do an expected value. So remember, multiply these two, add them to the product of this, add them to the product of this, add them to the product of this. So basically, you're multiplying these two again, and that's what you call the expected value. Thank you.